I had thought getting a list of running processes in a system would be a little bit more work and a little more complex than uh, how it really is in C# and .NET. So I wanted to show that because I thought it was really cool of how little code you need to actually get this done. And I think it really shows a lot of how much higher level languages and frameworks really do for you and abstract away for you, and how much maybe some people take what they give for granted. So anyway, I just have the same old empty console project here. So all you need to do to get a list of processes is start by using the system.diagnostics namespace. And I'm going to start by storing the array of process objects in this local variable inside of the main method. By just calling process.get processes. And that's really it, which is really nice. All you need to do now to get information on these is just loop through them. Or, I guess it depends on what you're, sorry. I guess it depends on what you're really doing with this data, but here's just an idea. So, let's just write each process name out to the console. So when I run this, we should just get a long list of processes on my system. Oh, I have to do one more thing too. So that read key to hold the console window open. So yeah, you'll see the usual list of processes in Microsoft operating system. So that was actually a little bit messy. It kind of just mixes it all together. So Chrome being very modular and having multiple processes to handle everything it does underneath, you'll see Chrome is kind of listed in a bunch of different places. Chrome. So I just want to clean this up really quick to make it look a little bit nicer. So I'm just going to sort the list of process objects before we actually write them out to the console. So just passing it to this array.sort method isn't good enough because I actually want to sort based on the process name and compare on the string value of the process name itself. So the way you can do this is just use a delegate as the second argument. Which is kind of like an anonymous function, really, if you want to say it that way. So this is going to define how these items are going to be sorted. So all I'm going to do is just return p1.processName, compare it to p2.processName. Okay, so now when I run this, we should get a better list. Yeah, that's nicer. So it's the usual SVC hosts. We see a whole bunch of Chromes. It's all sorted and looks a little bit nicer. So there's lots of other things you can do with this too. I mean, you can get so much information. Well, you won't be able to get all the information that you could using C# and .NET. You can get quite a bit. Certain things that are much lower level, like getting low-level context information of the process or its window, or certain things just aren't exposed through .NET like this. But chances are, whatever is here is probably what you'll want to use anyway. So you can see that. I mean, there's so much information. You can get a whole bunch of information on the process's memory usage, page, virtual working set, should be a private set, private memory size, how much time is spent in kernel mode that this process is executing. The affinity of the process. I think there's a kill. You can kill it. Yeah, get the ID. Pretty cool. So lots of stuff. Handle. Yeah. I think I just thought this was great, so I kind of wanted to show this off. Let's just get the peak working set, I guess. Why not? Of each one. So we'll run this, and you can see for each process, right underneath is its corresponding peak working set value that I'm getting. So pretty cool, really easy, not very many lines of code. I mean, I think the abstractions that this provides is great. It's very minimal and clean, so definitely handy.